All right, so what this is really saying is that if you have the same bases, you can add your exponents together. So right here, if I go to product of powers, this is a to the m times a to the n is equal to a m plus n. Same thing. Same bases, different exponents. Keep your base, add together your exponents. Easy enough? All right. Let's put some real numbers on there. So all I've got for this today, because that is such a basic rule, is literally just some practice problems. And I'm not trying to overcomplicate this, and I'm not trying to underestimate it. I'm just trying to talk to you like a student. And therefore, if you don't understand something, unlike maybe some of your other teachers, just ask me. I'm not going to get frustrated with you. And if I do, I apologize. I'll work on my demeanor. But I want you to ask questions. I don't want you going home at night being stressed out and not doing your homework. It doesn't help anybody. It doesn't help me. It doesn't help you. All right, so for this one, do I have the same bases? Mm-hmm. Okay. So x to the 7th times x to the 3rd, if I add together my bases, becomes x to the what? Wow, that's really stinking easy. Okay. Questions on that first one? All of you are acknowledging you understand it. Tommy, you're acknowledging you get it? Okay. Let's go to the next one. Notice here now that I have negative 3 x squared times x to the 5th. To the 3rd. Thank you so much. I just went ahead and gave you the answer. Here's how I want you to think about this problem. This negative 3 is not really attached to that x squared. That negative 3 is really saying times x squared. Do we agree with that? Because I don't know what x is, so therefore I don't know what I'm multiplying negative 3 by. So if I wanted to write this problem out, I could write it out as negative 3 times x squared times x to the 3rd. Remember, I'm breaking it down. I'm trying to show you all the different pieces. Okay. Can I add together the x squared and the x to the 3rd? Why?
They have the same base.
They're the same base. So now I've got negative 3 times x to the 5th. Well, what is negative 3 times x to the 5th? We can't technically do it, but don't we agree that we can also write it as that?
Yes.
We're all okay with that. All right, well, let's keep going then. Over here, we have 5 times x squared times 2 times x to the 4th. Is everybody okay with that? Let me ask you this. Can I combine my two exponents? Why? Because they're the same base. I know it sounds like I'm asking the same question over and over and over. Guess what? I am. And if I add those together, I now have 5 times 2 times x to the 6th. What else can I do to simplify this problem? Yeah, think up, Roger. Think up. 5 times 2, which is what?
10.
So now I have 10 times x to the 6th, which is really 10 x to the 6th. Okay, are we good there?
Yep.
All right. Without me breaking this one down, can anybody tell me what you think this answer is going to be, Connor?
4x to the 7th.
4x to the 7th. Okay, now before I move on from that, since I didn't work it out, I don't want to leave anybody behind. Does anybody have any questions on how I was able to come up with that answer? Feel good? Okay. Excuse me? Yeah, we're going to go through all of them. All right. How about 5? How about 5? What do you think, JT?
2x to the 10th.
Are we all okay with that one? All right. Awesome. Now, let's move on to this next one. I'm going to ask you a question, and I want you to just answer it honestly. Can we just have a floating negative? What number is really represented by this floating negative?
1.
Negative 1, right? I'm going to break it down. Is everybody okay with why I have a negative 1? Negative 1 times x to the 5th times 3 times x. Broke it all down. Are we okay with that? Breaking it down is so key. I know as a middle schooler, you hate writing steps out. I get it. I totally do. But I'm telling you, if you take the time and write them out, it will make it easier and you won't have to do it forever. But right now, your brains cannot process all those different things. I'm not insulting you. I just think most of you are going to struggle with that. All right, negative 1 times 3 is? Negative 3. x to the 5th times x to the 1st, same basis. What do I have to do with my exponents? Add them together. So Brian, you asked about this question. Do you understand why this one is only 1x? Because it's physically just 1, right? But since I have 5 over here and 1 over there, I still got to put them together to give me 6. Okay? So now I end up with negative 3x to the 6th. Okay, now I want to show you, I'm going to kind of detour this problem real quick. So we're going to do this one a little bit differently. I'm not changing the process. I'm just showing you a specific step. Do we agree that this is 6x's?
Yes.
And this is 2? Well, if I add up my 6x's plus my 2x's, don't I get 8x's? That's why we can do the policy this way. But again, I want you to think about it this way. Why do we have to have the same base? Can anybody answer why we have to have the same base? Charger?
Because you can't have the same variable, or like say it was like a c there instead of an x, or an x times c. You can't do that.
Yeah, because then I would have 6 x's and 2 c's. And if those are both variables or unknown numbers, well, who the heck knows what x is and who knows what c is? They can be different, so combining them doesn't ever work out. And it would be the same thing if we had just numbers. So like if I had, I'll get back to that one. This one we're going to get 7x to the 8th. And can anybody tell me what the last one's going to come out to be? Brian, go for it.
No, I can't see.
5x to the 12th. All right, how do we feel about that? Do we feel okay? Yeah, what's up, Ben?
This is kind of like a little thing.
Yeah, absolutely.
So, when you say like 7 x 9, could I just put like 7 times x?
I would rather you write, that's the correct answer, writing it out that way.
Okay.
It wouldn't be wrong technically, but that would be like me, best way I can describe it is, do you know what conjunctions, I think they're called, like words like do not, and we write it as don't? Conjunctions, thank you so much. If you were always like, I do not go to the bathroom, I do not wash my hands, it just sounds more formal, right? Where if you say I don't, it's a little bit more casual. They're not, either one's wrong, but it's just more fluid when you shorten it. And in math, we're always trying to make things shorter and smaller. Okay? Cool. All right, thoughts on this? All right, we're going to go to our homework assignment. Because I feel like this is where a lot of us will get a little bit lost on. So I'm going to go ahead and open up the next page. Feel free to jot some of this down. I'm still recording, so this will be on there if you need it. Okay, so when I open this document, we're going to have a little bit of a change, so just be ready for it. You are doing the first 15 questions. The first 15. 1-5. 1 through 15. If we get to 16, notice that we're now doing a different type of problem. You don't know how to do that one yet. Could you teach yourself? I absolutely believe you could. We're not there yet. We're doing 1 through 15. Do you understand?
Yes, sir.
Okay. Now, I want to take a few minutes because obviously going from our notes to our assignment, they're going to add a little bit more steps to it. But I just want to show you a few that it's not that big of a deal. It's the same idea. Okay, so number 1, I have 3y squared times 4xy squared. We can still break up this problem all the way. We can still break this up by writing 3 times y squared times 4 times x times y squared. Do you understand why I was able to break it up that way?
Yes.
Because I don't know what y squared is. So technically this is 3 times whatever y squared is. Are we okay there?
Yes.
All right, now, what can I multiply 3 by?
4.
Okay, so here's what I'm going to do. I'm going to cross out the 3 and the 4, which gives me 12. Now I've got y squared and y squared. Same bases, different exponents. What do we do with their exponents? Add them together. So we have y to the 4th. And do we have anything to do with our x?
No. Wait, yeah, no.
There's only one x, right?
Yeah.
So there's only one x. Can I add anything to it?
No.
Now here's why I wrote it this way. I like to write mine in alphabetical order. You do not have to. 3 times 4 gave me 12. 3 times 4 gave me 12. One singular x. Y squared times y squared gave me y to the 4th. Easy enough? Yes, Connor.
Okay, so I'm pretty sure because on the homework last night, I guess whenever we did that, I thought the x and the y were together, so they're not together.
Nope, because they're 2 separate variables. Okay, questions on that one?
And that's the answer.
That's the answer. All right, let's jump over to number 2. Number 2 looks a little crazy. Number 2 looks a little more wild. Step 1 is I'm going to break it all down. 2 times y times x to the 4th times 4 times x to the 3rd times y to the 3rd times 2 times x to the 4th times y to the 3rd. Okay, let's start with our numbers first. 2 times 4 is what?
8.
Times 2 is?
16.
Everybody okay with that?
Yep.
I'm going to rewrite it though. We're going to have 16 times y times x to the 4th times x to the 3rd times y to the 3rd times x to the 4th times y to the 3rd.
That's a lot.
Y, and y. How many total y's do I have?
7.
16, y to the 7th, we'll rewrite it at the end, times x to the 4th, times x to the 3rd, times x to the 4th. How many total x's do I have?
11.
So it's going to be 16, x to the 11th, y to the 7th.
Wait,
Okay,
what problem are we at?
2.
number 2.
So we're doing a lot
So,
of
oh,
addition.
I was reading.
Excuse me?
We're doing a lot of addition.
Yeah, so again, the whole focus this week is I'm trying to get you comfortable with all of the exponent laws. So this is what happens when we're multiplying, because the word product is multiplying, answer to multiplication of powers, multiplying with powers. We have quotient of powers, which is when we're doing division. Power of a power, which is when we're just multiplying with parentheses. I'll get you to that one. Rational exponents will be next week, and then negative exponents when we flip them. It's a lot of steps, but that's why we're breaking it up day by day, because as we go day by day, they get easier. And they all just kind of cycle back into each other. Yes, Andy?
So 1 through 15 is just combining everything and then getting base exponent, and then
Sorting and addition.
Yep, sorting and addition. But I want you to hear me out on this, though, y'all. As we continue to sort and add, we're going to be adding other steps to this. And as we add other steps, the more shortcuts that you take, the more likely that you're going to mess up. Understood? Today should be the easiest one. But again, if you didn't understand yesterday's assignment,